Good day, viewers. You are welcome back to Aliphatic Teaches. Today, we are going to be talking about chemistry, particularly the definitions and calculations of pH. Before we move on, if you are a new member on this channel, kindly subscribe and hit the notification bell for my subsequent content. Now, let's look at the definitions of pH. pH can be defined in different ways. We're going to look at the three definitions. One, the pH of a solution can be defined as the concentration of hydroxonium ion or hydrogen ion in a solution. Two, the pH of a solution can also be defined as the acidity or alkalinity of a solution. The third one, the pH of a solution can be defined as the negative to the logarithm to base 10 of the hydrogen ion concentration or hydroxonium ion concentration of the solution. Now, let us express this definition mathematically. pH is equals to minus log to base 10 of hydroxonium ion concentration, or pH equals to minus log to base 10 of hydrogen ion concentration. These two formulas can be used for calculating our pH, for our pH of any solution. Example 1 reads, calculate the pH of pure water at 25 degrees Celsius if the hydroxonium ion concentration is 1.0 times 10 raised to the power minus 7 mole per dm cube. Now in this question, we are asked to find the pH of pure water. We are given the concentration of hydroxonium ion to be equals to 1.0 times 10 raised to the power minus 7 mole per dm cube. From here, we call our formula for pH of hydroxonium ion to be equal to minus log to base 10 of concentration of hydroxonium ion. Now let us apply this. We have minus log to base 10, concentration of 1.0 times 10 raised to the power minus 7. We express it as minus log to base 10. Let us open this bracket here and open this bracket as well. So log to base 10 of 1.0 plus log to base 10 raised to the power 10 raised to the power minus 7. Concentration. So we have minus log 1.0 to base 10. Then in mathematics, minus 7 will come here in the rule of logarithm. So we're going to have plus minus 7 in brackets log 10 to base 10. So from here, we have our pH to be equals to minus log 1.0. When you take our calculating machine and press log 1, because our calculator is in base 10. So pressing 1.0 log, we are going to have 0. Then plus times minus, we have minus 7 multiplied by log 10 to base 10 as the rule of mathematics equals to 1. So we have minus 0 minus 7 times 1, we have 7. So 0 minus 7 give us minus 7. So we have minus multiplied by minus 7. Our final answer equals to 7. So the pH of pure water here is equals to 7. Example 2. What is the pH of a solution containing, question A, 0.01 mole per dm cube of HCl, question B, 0.01 mole per dm cube of H2SO4. Now to solve this question, we have to find the pH of two different acids, hydrochloric acids and tetraoxosulfate 6 acid. For the first one, hydrochloric acid, when we dissociate this acid, we're going to have hydrogen ion concentration plus chloride ion. Now the mole ratio for this acid, the mole concentration of the acid is 0.01 mole. So that is 1 mole from this place. Likewise, this also is 1 mole. So it's going to be the same, 0.01 mole. Now, going back our formula, pH is equal to minus log to base 10 of hydrogen ion concentration. So we have minus log to base 10 of our concentration of hydrogen ion here is 0.01. In our standard form, we need to shift this decimal point to the back of the first digit number. That is the first significant number that is there. 1, 2. We shifted twice, so we have minus log to base 10. So 1 multiplied by 10 raised to power. This point changes to minus. Then we shifted twice, that is 2. Or you count the number of zeros that is here. 1, 2. So we have this. So from here we have minus, open our brackets, log to base 10 of 1 plus the multiplication chain to plus log to base 10 of 10 raised to power minus 2. So from here, let us proceed. So we have our pH to be equals to minus, open bracket, log to base 10 of 1 plus, then this minus 2 move forward, we have minus 2. Then log 10 to base 10. So from here we have minus, open your bracket, log 1 base 10 give us 0. Plus times minus, we have minus 2. Multiplied by log 10 to base 10 give us 1. So we have minus 0 minus 2 times 1, we have 2. So 0 minus 2, we have minus 2. So our pH equals to minus times minus, we have plus 2. So that's the pH of the hydrogen ion in hydrochloric acid. The second question is to find the pH of a solution in tetraoxosulfacic acid, that is H3SO4. When we dissociate this as well, this subscript moves forward. We have 2H plus, then plus SO4, 2 minus. So the concentration of H2SO4 here, we have 0.01 mole. That is when our H2SO4 is of 1 mole. While our hydrogen ion here is 2 mole, meaning that it's going to be 2 multiplied by 1 mole for hydrogen ion, we have 0.01. So this gives 0.02. So 0.02 mole for hydrogen ion concentration. Now using our formula, pH equals to minus log to base 10 of hydrogen ion concentration. So we have minus log to base 10 of 0.02. So when we shift this, we have 1, 2. So we have minus log to base 10 of 2 multiplied by 10 raised to power. This is the decimal point changes to minus. Now we shifted twice, raised to power minus 2. So when we open this bracket, we have minus log 2 base 10, open a bracket here, plus log 10 raised to power minus 2 to base 10. So from here, we say pH equals to minus log 2 to base 10, then plus, minus 2 here moves forward, we have minus 2 log 10 to base 10. So here we have minus. When you take your calculating machine and press log 2, earlier example we said that our calculator is in base 10. So pressing log 2, it gives 0.3. Plus and minus, we have minus 2. Multiplied by log 10 to base 10 gives 1. So we have minus 0.3 minus 2 times 1, we have 2. So we have our pH to be equals to minus 0.3 minus 2 gives minus 1.7. So our final answer for pH equals to minus times minus plus 1.7. The next question reads thus. A solution has a pH of 4. What is the concentration of the hydroxonium ion? Here we are given a pH of 4. The pH equals to 4. We are told to find the concentration of hydroxonium ion. That is unknown. Now from our formula of pH involving hydroxonium ion is equals to minus log to base 10 of concentration of the hydroxonium ion. So our pH here is 4 equals to minus log to base 10 of oxonium ion. From here, multiply both sides by minus 1. So here we have minus 4 equals to log to base 10 of the concentration of hydroxonium ion. Let the unknown go to the left-hand side, that is log to base 10 of the oxonium ion concentration equals to minus 4. From here, to get my oxonium ion, I'm going to have, it's going to be to an anti-logarithm. So oxonium ion concentration equals to anti-logarithm of minus 4. That is to get the concentration of the oxonium ion. Since this is a logarithm of 10, and we want to get the value of this concentration, it should now be equals to the anti-logarithm of this value. So using our calculating machine, we press shifts on it, or we have second function 2h⁻nd. That is called second function. Either one, we are going to press shifts, then we press log. So when we press it, we have our values to be equals to 1 multiplied by 10⁻⁻⁴. So in mole per dm cube. So this is the concentration of the oxonium ion. So this is the first lesson in the pH calculation. For my subsequent lesson, kindly click the notification bell and don't forget to share and like so that other learners can also benefit from this beautiful channel. Thank you.